I'm Adrita,
I'm Jaden.
and today we'll walk you through a step-by-step framework for FLL mission analysis.
And to make it more clear, we'll use two examples from this year's Unearthed season.
And to make things even easier for you, we've made a ready-to-use file that is in the description.
You can then take it and just use it right away.
So why should we do mission analysis? The FLL robot game is not a mission to the moon or anything, but it can still be quite challenging. You only have 2.5 minutes to complete 15 missions that are scattered all around a map, and they all range in difficulty from simple to complex. Also, you need different basic mechanisms to solve them.
All right, so the mission analysis process is quite similar to the engineering design process and uses some of the similar ideas to guide you through approaching a mission and solving it. So to the right, you can see the key points that are part of the mission analysis. To start off is making sure you understand what each mission requires, which you can find in the game manual, and this includes which tasks they are and how you can complete them. Then you should look at the points that each task gives, and then assign them a difficulty level from 1 to 10, with 1 being easy and 10 being hard. Using the points in the difficulty level, you can gauge how valuable a mission will be. So you usually want to solve missions that give more points and are easier. So you should tackle these missions that are more valuable first. So another thing you should look at is what attachments you could use to solve the mission in each task. After that, you should see how you want to navigate to the mission and what techniques you want to use. Using the possible attachments and the possible navigation, you could then determine which missions would be likely to combine with. So missions that are closer by or could use the same mechanisms or same attachments to solve. So finally, if you have any additional notes specific to each mission, you can add them if necessary. So using this mission analysis process can be very crucial as it helps you to outline your process of solving a mission step by step. Judges want to look for how you solve your missions, so having the mission analysis ready can be very helpful as it can clearly present what you did to solve each mission.
All attachments perform a certain involved motion. This can be pushing, pulling, lifting, dropping, dumping, or collecting, and there's many more. For these involved motions, we have created different types of attachments, such as a power transfer module, a dumper, gearbox, rack and pinion, or a one-way door. Those are the ones you'd probably use the most during this year's season.
Here are the navigation types. So you can generally split navigations into two categories, basic and advanced navigation. So starting off with basic navigation, in the route number one, label number one, and label number two, those are all examples of basic navigation. As you can see, it utilizes just drive straights, simple turns, and there are stops in between each move. However, even though it might be simple, there's definitely a lot of things you want to consider. Uh, Specifically, in this diagram, there is a difference between route number one and route number two. And even though they both start from the home area, the first one it requires 2 turns, which can take a lot more time compared with the second route, which only requires 1 turn. And you can just do this by changing the rotation of your robot and alignment in the home area. The second type, advanced navigations, you can see in route number three. And as you see in the graph of the navigation, it is continuous, so there's no stops. And this generally is more complex, but it can be done more efficiently and faster. Uh, in this instance, how number three was done is the powers of each wheel were graphed out when following the path. Then plotting this out and using a line of best fit, you can assign an equation for the power of each wheel and plug this in into your program. This also requires using Python instead of just word blocks. And as you might tell, it is a lot more complex, takes more time um, to tweak, but in the end result is it could make your robot navigation a lot more smooth and faster. Another thing you want to know is the use of jigs. Jigs can be very helpful for your alignment in the home area, as sometimes you might not be able to place the robot in the same place every single time. So using a jig like the triangle one in the right or a rectangular one in the main diagram can help you align your robot faster and more precisely.
This is the mission map for the 2025 First LEGO League Challenge Unearthed. There are 15 missions in total, each labeled MO1 to M15. Each mission represents a different archaeological or excavation themed task. The teams will need to design, build, and program their robot and complete as many of these missions as possible within the match time of 2.5 minutes. Understanding the mission layout and is key for strategy and robot design. Now, we'll go into detail on a few missions, but this gives you the full picture at a glance. Mission 6 is called Forge. The task? Release all the ore blocks from the forge, and each ore block released scores 10 points. One block has a hidden artifact, so careful, release is key. Maximum points possible come from releasing all the blocks. Here's our mission analysis. We decided to use an active lift arm and start from the right home using basic move forward and turning functions. This is because this mission is directly north of the right launch area, so all we have to do is move forward and turn at about a 45-degree angle. We also considered combining it with Mission 7, or heavy lifting, because this mission is located directly behind the forge. A thing to consider is that if you were to combine it with MO7, you might have to do that mission first because the ore may impact navigation. Here is our solution, an active lift arm with a simple move forward and turning code. And this is the demo.
Here is another example analysis for Mission 10, Tip the Scales. In this mission, there are two tasks that you need to complete. First, you may have to make sure the scale is tipped and touching the mat. This grants you 20 points, alongside the scale pan, which you have to completely remove, which grants you 10 points. For our analysis, we split it into the two tasks, and we decided to give it a difficulty level of 3. Both of them are the same difficulty in this case, since you can complete both tasks in the same one motion. So this is also noted in additional notes, which is something that you can use to write down these types of things. So given the difficulty level and the points, we can determine the value, which is just the points divided by difficulty. And since each individual task, they have a different value, but since it can be done at the same time, we can add the value to 6.6 plus 3.3, which is around a value of 10. So this is a pretty good value, and it can provide you quite a bit of points without requiring too much difficulty. So the attachment type that we use is a sort of a fork with downward beams, or alternatively, you could use a hook to latch onto the loop. So the location is in the center of the field and slightly to the right. And to navigate there, you can start from the right home area since it's the closest and utilize some simple move straights and turns to reach your location. So the missions to combine with, you could possibly combine it with salvage operation, what's on sale, or angular artifacts due to the distance, and since it won't be too hard to navigate to them. However, it is worth to note that these missions would require a different set of attachments, so we couldn't use the same fork or hook to solve it. So mainly it's just because of the distance. All right, so here is our solution that we did for this mission. The attachment, as you can see, we decided to opt for a fork with downward beams, and this is simply just attached to the front of the robot on a power transfer. For the jig, we used a simple rectangular jig that connects the wall to the outer border of the home area. For the alignment, we just used the third thin grid line above the first dark black gray line. So for the navigation, it is also quite easy and fast, as we just start from the home area, drive straight, turn 90 degrees to face the mission, drive there, set down the fork, and then drive back, completing the mission, then returning to the home. Here is a demo of our solution.
Thank you for watching this video. Make sure you like and subscribe so you can be notified when we post the more in-depth videos about programming FLL robots. If you have any questions, feel free to leave us a comment down below or reach us through our email.